Hello and welcome to part 3 of the GCSE Maths Foundation Tier walkthrough. So this is the third paper in this series and it's a calculator paper. So as always, please follow along at home. I've put the link to this paper in the video description. And if you haven't already done so, please have a look at paper 1 and paper 2. So hopefully you've got all of the equipment ready at your fingertips. So without all out of the way, let's get cracking. Question number 1. Write the number 5,689 correct to the nearest thousand. So this is our number. Let me just write it down here. 5,689. And we need to round it to the nearest thousand. So this is our thousands place value. So it's either going to round down to 5,000 or up to 6,000. And to determine whether we go up or down, we look at the number next to it. So because we've got a 6 here, this tells us to round up. Remember, if this digit is 5 or greater, we round up. If it's less than 5, we round down. So because it's 5 or greater, we round this number up. So it's going to round up to 6,000. So that is our answer, 6,000. Question 2. Work out 30 plus 12, all of that divided by 5 plus 3. Now remember, this is a calculator paper, so we can just type this into our calculator. So the first thing to type in is the fraction key. Okay, there should be a button like this. So this button should be on your calculator. So just press that. Go to this, put your cursor in this box, and then just type in 30 plus 12. And then go down and press 5 plus 3. Let me just do that. 30 plus 12 divided by 5 plus 3. And in your answer, you will get 21 over 4. Now, you can leave it like this, 21 over 4 as your answer. That's absolutely fine. Or you can write it as a decimal. So if you press the SD button on your calculator, that converts it into a decimal, which gives you 5.25. So either one of these is perfectly fine to have as your answer. Now, if you don't have this fraction button on your calculator, you'll just have to type it in using brackets. So you'd have to type in brackets 30 plus 12 and then close brackets and then the divide symbol and then another set of brackets 5 plus 3. Okay, and this will also give you the exactly the same answer. Question 3. Work out the reciprocal of 0.125. So what does the word reciprocal mean? Well, the reciprocal of a number is just some number that we multiply this number by in order to get an answer of 1. So essentially what we're doing is we're trying to work out what we multiply this number by to get 1. So we've got 0.125 times some number, and that will give us an answer of 1. So to work out what this missing number is, we can just divide by 0.125. So 1 divided by 0.125. And when I put that into a calculator, we get an answer of 8. So the reciprocal of 0.125 is 8 because when we multiply these two numbers together, we get an answer of 1. So our answer is 8. Question 4. Here is a list of numbers. From the list, write down a multiple of 4. So a multiple of a number is just a number in that number's times tables. So if we think about what the multiples of 4 are, we've got 4, 8, 12, and I can stop there because I can see that 12 is a multiple of 4. That's the first one. So none of these are multiples of 4 because we would have come across them by now. So the answer for this one is 12. Now let's look at part B or II. So from the list, write down a prime number. So a prime number is a number that only has 2 factors. So is 1 a prime number? No, because 1 is the same as 1 times 1. The only factor of 1 is 1. So it only has 1 factor. So 1 is definitely not prime. Is 2 prime? Well, the factors of 2 are 1 and 2. And that's it. There's no other factors of 2. So let me just circle that. We've got 2 factors. So this is prime. Okay. So our answer is going to be 2. Let's just check the other ones. So 5, well, the factors of 5 are 1 and 5, 1 times 5. And again, that's all the factors. So actually 5 is also prime. So there's more than one answer for this, but it only says a prime number. We don't have to write down all of them. So you could have 2 or 5. Let's check the other ones. So 6. Well, the factors of 6 are 1 and 6, but we could also have 2 and 3. So this is definitely not prime. And finally, let's just cross it off here. 12. What are the factors of 12? Well, 1 times 12 is 12. 2 times 6 is 12. And 3 times 4 is 12. So again, 12 is definitely not prime. So our answers are 2 and 5. So I'll just put here 2 or 5. Whichever one you put will be correct. Question 5. There are 1.5 litres of water in a bottle. There are 250 millilitres of water in another bottle. Work out the total amount of water in the 2 bottles. So we need to add these 2 quantities together. Now at the moment they're in different units. So if we put them in the same units, so let's convert them into millilitres. So first of all, how many millilitres are there in a litre? Well, the prefix milli means 1,000. So there are 1,000 millilitres in 1 litre. So to work out how many millilitres there are in 1.5 litres, so 1.5 litres, well, we just need to multiply by 1,000. So 1.5 times 1,000, well, that is going to be 1,500. So we've got 1,500 millilitres plus 250 millilitres. So we can just put this into a calculator, but I can see that the answer is going to be 1,750 millilitres. So that's my answer. And I just need to be really careful because I need to include the units here. So my answer is going to be 1,750 millilitres. Okay, this is worth 3 marks. You would get 1 mark for the correct units in this situation. So you could either write it in millilitres or you could say 1.75 litres. Either one of these would be correct, but as long as you include the correct units. Question 6. Here is a trapezium, and we're told that this diagram is accurately drawn. Part A, measure the length of the line PQ. So for this question, I've printed off the sheet of paper because we're going to need to measure. So we're measuring the line PQ. Well, let's just first of all draw the line PQ. What line are we measuring? So it's this line here. So if I get my ruler out and I'm putting it on P and measuring to Q, that's exactly 7 centimetres. So that's the answer for that one, 7 centimetres. And part B, measure the size of the angle marked X. So in this situation, we are measuring this angle. So I'm just going to get my protractor out for this question. I'm going to put my cross on the vertex and then measure the angle. And this one is 35 degrees, exactly 35 degrees. So just be careful with this. Always do a dummy check to see if that looks realistic. Because remember, on the protractor, there are 2 numbers. So make sure you're reading off the right number. If you did get 145 degrees, well, you've obviously read off the wrong number. So just do a dummy check to make sure that that is correct. Question 7a. Solve this equation here. So first of all, let's simplify. We can collect like terms. So f plus 2f, that gives us 3f. Plus another f, we are left with 4f. So we've got 4f is equal to 20. And now to get f on its own, we can divide both sides by 4. So if we divide both sides by 4, we get f is equal to 5. So our answer is 5. Now the second part, we've got to solve this equation again. So solve 16 minus m equals 6. Now here you may immediately see that 18 minus 12 equals 6. So my answer is 12. But just doing this algebraically, if I want to get m on its own, well, at the moment we've got minus m. So let's get m on the right hand side to make it positive. So if I add m to both sides, I'm left with 18 is equal to 6 plus m. And now to get m on its own, I can take away 6 from both sides, and I'm left with 12 is equal to m. So just showing you the algebraic way of doing it, getting an answer of 12, but you may have just been able to see that 18 minus 12 equals 6. Okay, and then the last part of this question, simplify d squared multiplied by d cubed. Now this is one of our laws of indices. So when we multiply things with the same base, we add our indices together. So we add these indices together. So d squared multiplied by d cubed, well, it's going to be d to the power of 2 plus 3. Oh, 2 plus 3 is 5. So this is just d to the power of 5. So that's our answer, d to the power of 5. Question 8. Jane writes down the following. 3.4 multiplied by 5.3 equals 180.2. Without doing the exact calculation, explain why Jane's answer cannot be correct. So we're told not to do the calculation. We just need to say why this is wrong. Now I can see that if we round the numbers, so the calculation is going to be approximately 3, because I'm just rounding this to one significant figure, multiplied by 5, which gives us an answer of 15. And we can clearly see that 15 is no way near 180.2, so she must be incorrect. So what can we say as our answer? So we can say that the calculation is approximately equal to 15, and then I'm just going to put in brackets 3 times 5, and we can just say which is a long way off 180.2. So she's nowhere near. We know that she's definitely wrong because we've just rounded the numbers. Question 9. The two numbers a and b are shown on the scale. The difference between a and b is 48. Work out the value of a and the value of b. So we know that the difference between these two numbers is 48. So we are also told we've got these lines in between them. So if a is here, let's see how many lines we need in order to get to b. So we've got 1, 2, 3, 4, 5, 6. So we can say that 6 lines must be equal to 48 because the difference between them is 48 and there's 6 lines that separate them. So now we can work out what each line is. So if 6 lines equals 48, one line, well, we're just going to divide both sides by 6. So 48 divided by 6 gives us 8. So one line is equal to 8. So now we can work out a and b because we know that this is 0. So a is going to be equal to 0 minus 8 minus another 8. So take away 8, take away another 8. Well, that's just going to be negative 16. And then b, well, we're going up this time, so it's going to be positive. So we're going up 1, 2, 3, 4 lots of 8. So we can just say 4 times 8. I could have written 8 plus 8 plus 8 plus 8. I've just written 4 times 8, which is 32. So a is equal to negative 16 and b is equal to 32. And you could do a dummy check of your answer. So if you work out the difference between these two numbers, you will get 48. Question 10. Complete this table of values. So we've got 2 missing boxes here. So we're told that when n equals 12, what does 3n plus 12 plus 2 equal? Well, wherever we see an n, we're just going to replace that with 12. So in this box, it's going to be 3 times n. Well, n is 12. So it's going to be 3 times 12 plus 2. Well, 3 times 12 is 36. It's going to be 36 plus 2. Well, that just gives us 38. So in this box, we've got 38. And now in this box, we need to work out what the value of n is. Now, we're told that 3n plus 2 is equal to 47, so we can write that out as an equation. So for this box, we can write out 3n plus 2 is equal to 47. And remember, we're just trying to work out what n is. So to solve this equation, first of all, let's subtract 2 from both sides. So we're left with 3n is equal to 45. And now we can divide both sides by 3. We get n is equal to 15. So our answer here is 15. And we can check our answer by working backwards, or by working forwards, I should say. So when n equals 15, 3n plus 2, substitute 15 where n is. It's going to be 3 times 15, which is 30. Sorry, not 30. 3 times 15 is 45. And then 45 plus 2 does give us 47. Question 11. The same number is missing from each box. The same number. So these numbers are exactly the same. Find the missing number. Now we do have a calculator. You could do trial and error. So you could try 1, 2, 3, 4, 5 and so on. But because we know they're the same number, we are trying to find out what the cube root of 343 is. If there are only 2 numbers, it would be the square root. But because we've got 3 of them, we're looking for the cube root. So on your calculator, there is a button that is the cube root. So if you press shift on your calculator, if you press shift and then the square root button that looks like this, so shift and square root button, that gives you the cube root. So that gives you the cube root. And now because you're finding the cube root of 343, you can just type in 343 into that box. Let's do that. Cube root of 343 and you get 7. So that's our answer, 7. So just what that means is 7 times 7 times 7 is 343. Okay, part B, it says work out 4 to the power 4. Now 4 to the power 4 is not 4 times 4. Okay, a lot of people make that mistake and just want to multiply these numbers together. We're not doing 4 times 4. We're multiplying 4 by itself 4 times. So 4 to the power 4, well that's equal to 4 times 4 times 4 times 4. And again, we can put this into a calculator. So we could write 4 to the power 4, or we could just write 4 times 4 times 4 times 4. And we get 256. So that is our answer, 256. Question 12. Here are 2 numbers. Nadia says both of these numbers can be written as the sum of 2 square numbers. Is Nadia correct? You must show how you get your answer. So let's just go through some terminology here. The word sum, well that just means add. So what we're doing is we are finding 2 numbers, 2 square numbers, that when you add them together, you get these 2 numbers. So first of all, let's think about 29. Can you write 29 as the sum of 2 square numbers? And for this, I think the easiest thing to do for this is just to write down our square numbers. So let's just list them. So we've got 1. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. I don't think we need to go any further than that. So can we write 29 as the sum of 2 of these numbers? Well, yes, we can. I can see straight away 4 and 25 give us 29. So 25 plus 4. So what about the other one, 37? So 37, can we write that down as the sum of 2 square numbers? Well, again, we can. I've noticed that 36 plus 1 is 37. 36 plus 1. So we need to answer the question, is Nadia correct? Well, we would definitely put, that's a very strange why, but yes, she is correct. It says you must show how you get your answer. I've already done that. This is perfectly acceptable. I don't need to write an explanation. You can see, or the examiner can see, that I've found both numbers by summing together 2 square numbers. Question 13. Here are the first 3 terms of a sequence. Find the first 2 terms in the sequence that are less than 0. Now, there's a few ways you could do this. You could just list out all of the numbers. And I think for this question, because the numbers aren't that high, that's what I'll do. So if we just write down the numbers here, 32, 26, 20. Now we need to keep going until we get 2 numbers that are less than 0. So what's happening with this sequence? Well, to go from 32 to 26, we're subtracting 6. To go from 26 to 20, we're subtracting 6. So the pattern for this sequence is to take away 6 each time. So if we take away 6 again, we get 14. We do the same. Take away 6, we get 8. We just keep repeating this process. Take away 6, we get 2. Not quite there yet. So take away 6 again, and we get -4. So that's the first number less than 0. So -4. But notice we need the first 2 terms. So the next one, we're going to take away 6 again, and we get -10. So our first number is -4, and our second number is -10. Question 14. Here is a triangle ABC, which we can see. Mark with the letter Y the angle CBA. Now, when we're dealing with angles, the letter in the middle tells us where the angle is. So the angle CBA, we're starting here. CBA, it's this angle. So it's always the one in the middle. So it says mark with the letter Y. So let's write that in. There we go. We've done part A. Now moving on, here is a cuboid. Some of the vertices, let's just highlight that. Some of the vertices are labelled, which we can see. So the vertices are just another word for corners. So we need to shade in the face CDEG. So let's find that first of all. So CDEG. So those are the vertices, C, D, E, G. Now the face is just a flat surface that connects these 4 points together. So I'm just going to make my pencil a bit thicker to shade in. So obviously this doesn't need to be perfect. So as long as the examiner can see the face clearly, it's this face here. So that is good enough for our purposes. So that is the face CDEG. Okay, let's go on to part C. How many edges, let me again highlight the key word here. How many edges has a cuboid? Well, an edge is just one of these lines. Let me highlight it to make it clear. So this here, this is an edge. So I already know the answer, but let's just count them. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, but we've got the ones that we can't see as well. So 10 down here, 11 across here, and then we've got one more here, which brings us to a total of 12. So that is our answer, 12 edges. Question 15. There are 5 grams of fibre in every 100 grams of bread. A loaf of bread has a weight of 400 grams, and there are 10 slices of bread in a loaf. Each slice of bread has the same weight. Work out the weight of fibre in 1 slice of bread. Okay, there's quite a bit to this. This is worth 3 marks. So first of all, we're told that a loaf of bread has a weight of 400 grams. So one loaf, you can say that one loaf is equal to 400 grams. And we're also told there are 10 slices of bread in a loaf. So to work out the weight of a slice, well, we can just divide this by 10 because there's 10 slices in a loaf. So one slice, so we need to divide this by 10. Well, that's going to be 40 grams. Now at the top we're told that there are 5 grams of fibre in every 100 grams of bread. So if we write down the ratio of fibre to bread, well, we know that there are 5 grams of fibre for every 100 grams of bread. And we need to work out the amount of fibre or the weight of fibre in 1 slice of bread. So we know that 1 slice of bread is 40 grams. So 40 grams, and we need to work out how much fibre there is. So we've got 3 numbers here and just 1 missing number here. So we can work out what this is. So to go from 100 to 5, well, we are dividing by 20. So 100 divided by 20 is 5. So if we do the same thing over here, if we divide by 20, that will give us the amount of fibre. So 40 divided by 20, well, that is 2. So there are exactly 2 grams. I just need to write 2 here because we've already got the grams. There's 2 grams of fibre in 1 slice of bread. Question 16. Give an example to show that when a piece is cut off a rectangle, the perimeter of the new shape is less than the perimeter of the rectangle. So what we're doing is we are cutting off part of this rectangle to make a new shape where the perimeter of the new shape is less than the perimeter of the rectangle. So I think the easiest way to think about this is just if I were to cut off, let's say I were to cut off down here, make a cut, and just to give me this smaller rectangle, so let's just draw it here. So this smaller rectangle, like so, we clearly see that the perimeter of the new shape is much smaller than the perimeter of the old shape. So let's just work out what the perimeter is just to verify that. So we're going along 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And now the perimeter of the new shape is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you can clearly see it is smaller. Now for part II, we need to do the same thing. We're going to cut off a piece of the rectangle, but the perimeter of the new shape must be the same as the perimeter of the rectangle. Now this might sound quite tricky, but actually it's quite easy. What we could do is if we just cut off a corner, then that gives us a new shape where the perimeter is the same. Because essentially what I'm doing is I'm losing this length here and this length. So I'm losing 2 here, but I'm gaining 2 here and down here. I mean, I could cut off any corner and it would still be the same. You know, if I cut off this corner here, that would also work. I would still get a perimeter of the same. Now I'm just going to verify that. So if I draw in the new shape, so I'm just going to draw in the new shape. So we're going to go up here, across, like that, up and then across. So that is our new shape. You can see that is basically I've cut off this square from my old rectangle. And I know this is 16. Let's just count the perimeter or work out the perimeter on this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we were correct. Okay, the last one. This time, again, the same thing, but this time the perimeter has to be greater than the perimeter of the rectangle. So the perimeter of the new shape has to be greater than the perimeter of the rectangle. So this time we're going to be a bit fancier and we're going to make a big cut. So let's say we start here, we cut down to down here, we go along and then we go up. So I'm cutting off this square of my rectangle. So my new shape is going to look something like this. So I'm going to go up here, down 2 spaces, across 2, up and then across. And you can see that I've just cut off this square. So let's count the perimeter. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And this one was 16. That's the same each time. So we are done. So we've found one where the perimeter is less than the rectangle, equal to the rectangle, and greater than the rectangle. Question 17. ABC is an isosceles triangle. When angle A equals 70 degrees, there are 3 possible sizes of angle B. What are they? So let's just draw in our rectangle. So we know that it's isosceles. So again, this is not a perfect drawing by all means. But if it's isosceles, we know that these 2 lengths are the same and these 2 these 2 angles are the same. Now it says that angle A is 70 degrees, so let's just say that's this one here. So angle A is 70 degrees. There are 3 possible sizes of angle B. What are they? Well, let's just say that this was ABC like this. Well, what is this angle over here? Apparently there's 3 possible sizes. So we can work out this angle because we know that this is an isosceles triangle. So this must be 70 degrees. So 70 plus 70 is 140. And because we know angles in a triangle add up to 180 degrees, B must be 40 degrees. So one of our answers is 40 degrees. Now that's not the only combination. I could have, if I draw our triangle again, this time, let's say that this was B. So ABC like this. So again, A is 70 degrees. And if I just put our lines in again, we know that these two are equal. So in this case, B is 70 degrees. We don't even need to work out what C is. Well, we know C is 40, but the main thing is that B is 70 degrees. Now, there is one more possible size of angle B. And if we just think about a slightly different triangle. So again, we know that angle A is 70 degrees. So if I were to just draw angle A like that, being 70 degrees. Now, it doesn't have to be that these two lengths are the same. It could be that this length and, I'll just make it the same, this length are the same. So this time, we've got a new triangle like this. And because we know that these two lengths are the same, these two angles must also be the same. So, because this is 70, if we do 180 minus 70, we get 110 degrees. So we know that these two angles must add up to 110 degrees. So to work out what one of them is, I mean, it doesn't really matter which one's B and which one's C because they're the same. We can just do 110 divided by 2, and that gives us 55 degrees. So B is 55 and C is also 55. Obviously, it's just asking for B. So the third possible angle will be 55 degrees. Okay, let's look at part B. When A equals 120 degrees, there is only one possible size of angle B. Explain why. Okay, now let's draw this again. So if I were to draw our triangle again, so we know that this is 120 degrees. This is A. Now we know that it's isosceles triangle. Now if it was like this, where these two lengths were the same and these two angles are the same, this would also be 120. But you can clearly see that this is not possible because we know that angles in a triangle add up to 180 degrees. And at the moment, we're at 240. So we're already over what we should be. So this just doesn't work. So this is impossible. So the only way for it to work would be for if this length and this length were the same and these two angles were the same. And let's just work out what these angles are. So we can do 180 minus 120, which gives us 60. And then do 60 divided by 2, which gives us 30. So these two angles are 30 degrees. But it says explain why there's only one possible size of angle B. So again, it doesn't matter which one's B and which one's C. Now, just going back to the question, it says there's only one possible size of angle B. Explain why. So we know that the answer is 30 degrees. So we could just first of all write it down. B is 30 degrees. And explain why. Well, we can't have two base angles of 120 degrees. So we can't have two base angles of 120 degrees. Question 18. In a breakfast cereal, 40% of the weight is fruit and the rest of the cereal is oats. Write down the ratio of the weight of fruit to the weight of oats. Give your answer in the form of 1 to n. Now, whenever we're dealing with ratios, we need to be really careful about the order in which we write our ratios. So it's asking us for the ratio of the weight of fruit to the weight of oats. So it has to be in this order. So we know that in the cereal, 40% is fruit. We can write 40 here. So if 40% is fruit and we're told that the rest of the cereal is oats, well, there must be 60% that are oats because obviously these numbers have to add up to 100. So we've got a ratio of 40 to 60, but we can simplify this. So you can see that both numbers are divisible by 20. So if we divide both numbers by 20, we get 2 to 3. Now, ordinarily, this would be this is in its simplest form. So ordinarily, this would be what we would write as a ratio, but it's not asking us for the answer in its simplest form. It's asking us for the answer in the form of 1 to n. So our answer has to be 1 to something. So what did we do to go from 2 to 1? Well, we just halved this number. We just divided it by 2. So if we divide the left-hand side by 2, we must divide the right-hand side by 2. So 3 divided by 2, well, that gives us 1.5. So our answer is 1 to 1.5. Notice we've written our answer as a ratio in the form of 1 to n. So it's 1 to 1.5. So this is n. N is 1.5. Okay, let's look at part B now. A different breakfast cereal is made using only fruit and bran. Only fruit and bran. The ratio of the weight of fruit to the weight of bran is 1 to 3. What fraction of the weight of the cereal is bran? So let's do the same thing. Let's write down our ratio. So this time we've got fruit and bran. So the ratio of fruit to the weight of bran is 1 to 3. And we need to work out what fraction of the weight of the cereal is bran. So 1 portion of fruit and 3 portions of bran. Well, the fraction that is bran is going to be 3 out of the total. Well, the total in this case is 4. Because if we've got 3 bran and 1 fruit, that's a total of 4. And out of those 4, 3 are bran. So that is our answer. Our answer is 3/4. Question 19. Boxes of chocolates cost £3.69 each. A shop has an offer. So the offer is 3 for the price of 2. Ali has £50. He's going to get as many boxes of chocolates as possible. How many boxes of chocolates can Ali get? So this is where the calculator is going to come in really handy. So they're 3 for 2. So if he buys 3 boxes, he's only paying for 2 of them. So they're £3.69 each. So to work out let's work out if he wanted to get 3 boxes, how much would that cost? So 3 boxes. Remember, he's only paying for 2. So it's going to be £3.69 multiplied by 2. So let's type that into the calculator. 3.69 times 2. And that's £7.38. £7.38. So he's got £50. So we can just go up in multiples of £7.38. So 6 boxes. 6 boxes. Well, it's going to be, we're just going to times this by 2. So it's going to be £7.38 times 2. That gives us £14.76. To work out what 9 boxes are, well, we're just going to add on another £7.38. So plus £7.38. That takes us up to £22.14. Now, there probably is a quicker way of doing this, but I think this is probably the most logical way of doing it. So 19 boxes. I'm just going to add on another £7.38. That takes us up to £29.52. So keep going. 15 boxes plus £7.38. We are now at £36.90. We can keep going. 18 boxes. So add £7.38. That takes us to £44.28. If we keep going, so 21 boxes this time. Again, we're adding £7.38. Oh, now that takes us to £51.66. So we cannot get 21 boxes. So we can buy 18 boxes. Now, can we buy 19 boxes? Because 19 boxes, well, we just need to add on £3.69 this time, because that's how much each box cost. So I'm going to take £44.28. So it's going to be £44.28 plus 44.28 plus 3.69. And that gives us, so let's just write it in here, plus 3.69. And that gives us £47.97. So yes, we can afford 19 boxes. So we obviously can't afford 20 boxes because that would be the same as 21 boxes, but we can afford 19. So how many boxes of chocolate can Ali get? Well, our answer is 19. Question 20. So we've got all of this information here, and then it says draw a Venn diagram for this information. So I'm just going to draw the Venn diagram first of all. You should always start with a rectangle on your outside, and that represents everything that we're going to include. So it's just this weird looking symbol here. That is for this. This is called the universal set. So I'm just going to write this down just to just a bit of context, a bit of what's it called? A bit of terminology, I should say. So this is called the universal set, and it includes everything. So all of these numbers are what we're going to put into our Venn diagram. And we've got sets A and B. So let's draw two circles. So that's going to be set A, and that's going to be set B. So set A and set B. And now we've drawn our Venn diagram, let's populate it with the numbers. So the first thing I'm going to think about is this here. Now this says A intersection B. So let's just write this down. So A intersection B. What that means is everything in set A and everything in set B. So it has to be in both sets. So the region that corresponds to is this here. So notice this shaded region is set A and set B. So we're told what numbers go in there. So we've got the numbers 2 and then number 6. Okay, now let's focus just on set A. So this set here, so just this circle. So we've got all of the multiples in set A. So let me just highlight that to make it clear. So we're going to put all of the multiples of 2 somewhere in this circle. We've already got 2 of the numbers, so we need to put in the other numbers. So the multiples of 2 are 2, 4, so 4 needs to go here. 6 we've already got, 8, 10, but we're not going to do 12 because that's not part of our universal set. We're only going from 1 to 10. So we're done. We're done with set A. Now let's focus on set B. So set B is this here. Now up here, let's just asterisk this. So this is A union B. So A union B. And what that means is everything in set A or set B. So either one of them. So A union B will just be everything in the circles. So we've already filled in some of them, but let's just think about what numbers we've got left over. So let's do this in a different colour. So 1, so everything that's left over must be in this sort of this region here. So 1, 2, we've already got 2, 3, we haven't got 3 yet. 4, we've already got 4, 6, we've already got 6, 8, we've already got 8. We haven't got 9 yet, so 9 is going to be there, and we've already got 10. So we've done that. Now we just need to look back at our universal set. Have we missed any out? We've got 1, 2, 3, 4. We haven't yet included 5, but it is part of our universal set. So we need to include 5. So 5 must be on the outside. If we carry on going, 6. We haven't included 7, so that must also be on the outside. 8, 9, and 10. So we've finished all of our numbers. So this is our answer. Question 21. The scatter diagram shows information about 10 students. For each student, it shows the number of hours spent revising and the mark the student achieved in a Spanish test, which we can see down here. One of the points is an outlier. Write down the coordinates of the outlier. Well, if we can see the points, we can see that there's a general trend of a positive correlation here, but this one here sort of messes that up. So this one is the outlier, so we just need to write down the coordinates of that point. So we go along the corridor up the stairs, so we're going along 4 units, so it's going to be 4 comma and then up 10 units, so 4 comma 10. Okay, part B. For all of the other points, draw the line of best fit. Now, there's a bit of an art form drawing a line of best fit. So let me just get my line tool out. So whenever you're drawing a line of best fit, you want to get obviously the direction correct, and you want roughly half the number of points on one side and half on the other side. So again, we can move this about a bit. At the moment that's a bit thick. Let me make it a bit thinner. So let's say this is our line, so I can move it about a bit, and obviously I can change the direction. So I think I'm just going to change it a bit like this. I think that looks about right. I think I'm just going to make it a bit steeper and just move it up a bit like this. Okay, make sure you do this in pencil. Okay, so you can rub it out again. Almost there. I'm probably being a bit too accurate, but I think that's about right there. So try and get it as accurate as possible, because usually you'll have to use this in the next part of the question. So let's go back to part B. So we've done the line of best fit. Now it says describe the correlation. I've already mentioned what correlation it is. It is a positive correlation. That's all you need to write. Positive correlation. Correlation. Okay, part C. So a different student revised for 9 hours. Estimate the mark this student got. So they revised for 9 hours. So we go along to 9, which is here. That's 9. And what we do is we go up to the line and then read along the mark. So again, I'm going to get my line tool out for this. So I'm going to go straight up like that. And now I'm going to go along. So I'm going to go along. And there is a margin for error with your answer. So with mine, in each of these squares, that is 2 marks, because it goes 62, 64, 66, 68, 70. Is that right? That's 60, 62, 64, 66, 68, 70, yeah. So this is 62. And I will have a look at the mark scheme to see what they allow for this particular question. So if you just bear with me while I look at the mark scheme. And it seems for this question, as long as you give an answer between 60 and 70, you get given the mark. So there's quite a wide margin for error with this particular question. So let's move on now. The Spanish test was marked out of 100. Lucia says, I can see from the graph that had I revised for 18 hours, I would have got 4 marks. Comment on what Lucia says. So she's saying that if she revised for 18 hours, so 18 hours, well, we'd go up and we can see that it's off the graph. So according to the graph, well, it looks like that you would get 100%, but that is not correct. And the reason it's not right is because she has extrapolated the data. And what that means is she's picking a point on the graph that is outside the data range. So if we look at the range of the data, the lowest score, or the lowest hours spent revising, is 2, and the greatest number of hours spent revising is this value, which is, I'm not quite sure exactly what it is, but it's between 12 and 14. So you can only make predictions within these 2 values. So what we can say is we can say that Lucia is wrong. Lucia is wrong because she has extrapolated. So something along those lines. So if you mention the word extrapolation, then you probably will get the mark for that. Okay, so that's called extrapolation. And just as a bit of further knowledge, you know, in case they ask, if you're making predictions within the data values, within the range, that's called interpolation. Okay, so interpolation is fine because you're using data within the range, but extrapolation is not fine. Okay, you cannot extrapolate. Okay, let's move on to we've done question 21. Now we're on question 22. So the length of a line, which is given as the letter L, is measured as 13 centimetres, correct to the nearest centimetre. Complete the following statement to show the range of possible values of L. So it's been rounded to 13 centimetres, correct to the nearest centimetre. So first of all, let's think about what the smallest value it could be. So the smallest value, well, that would be 12.5 centimetres, because if we're rounding this to the nearest centimetre, this would be rounded up to 13. But anything smaller than this would be rounded down to 12. So the minimum would be 12.5. And now that's called the lower bound. So let me just write that in there. That is called the lower bound. And now if we think about the upper bound, well, easy way to think about it is, this is half a centimetre below our value. The upper bound is half a centimetre above our value. So the upper bound will be 13.5 centimetres. Now you may be thinking, well, surely it can't be that, because if we were to round this to the nearest centimetre, it would be rounded up to 14. And you would be correct, but what this is saying is we're not saying it's equal to 13.5. We're saying that our length is less than 13.5. And that's why it doesn't have one of these equal signs. Okay, so our lower bound has to be equal to or greater than 12.5. So it can equal 12.5. But our upper bound has to be strictly less than 13.5. Question 23. Line L is drawn on the grid below. Find an equation for the straight line L. Give your answer in the form y equals mx plus c. So whenever we're writing an equation of a line in this form, we just need to know what these letters correspond to. So I'm just going to copy it out here. So y equals mx plus c. So the m, well, that is the gradient of our line, or the slope of our line. And the c, well, that stands for the y-intercept. So where does our line cross the y-axis? Well, we can see where it crosses the y-axis. This point here is 1. So we know that c is going to equal 1. And now we just need to work out the gradient. Now to work out the gradient, we do the change in y over the change in x. So the change in y over the change in x. That little triangle is just shorthand for changing. Okay, so you might also have heard it referred to as rise over run, but I like to think of it as change in y over change in x. So let's pick 2 points on our graph. So we can pick these 2 points here. So to work out the gradient, well, the change in y, we're going from 1 to 3. So the change in y is 2. And the change in x, we're going from 0 to 1. Well, that's just 1. So it's 2 over 1, which is 2. So our gradient is 2, our y-intercept is 1. So the equation of the line will be y equals 2x plus 1. Question 24. Jenny works in a shop that sells belts. The table shows information about the waist sizes of 50 customers who bought belts from the shop in May. So we've got the belt sizes and then the sizes in terms of the waist size and the number of people. Calculate an estimate for the mean waist size. So we can't calculate the actual waist size because we don't have the specific measurement. So we're only given intervals. So how we do this, to calculate an estimate, we always, first of all, choose the midpoint of our interval. So I'm just going to write in here MP for midpoint. So we're going to pick the midpoint for each of our categories. So for the small category, well, that will be 30 inches. Medium, that will be 34, and then 38, and then 42. And now what we do is we multiply the midpoint by the frequency. So I'm just going to put MP times F. So, well, we can use a calculator for this. So we're going to do 30 multiplied by 24, which gives us 720. And then 12 times 34, that is 408. 38 times 8 is 304. And then 42 times 6 is 252. And now we just add them all up. So 720 plus 408 plus 304 plus 252. So that gives us 1,684. Now what we've got here is we've got the total waist measurements for everyone. So to work out the mean, we just need to divide this by the number of people we've got. Now I could count up the frequencies, but I can see in the question that it tells us that there are 50 customers. So this frequency, if we add these up, we should get 50. So let's just verify that. 24 plus 6 is 30, 12 plus 8 is 20, and 30 plus 20 is 50. So we do get 50. So what we're going to do is we're going to do 1,684 divided by 50. I'm going to divide that by 50, and we get 33.68. 33.68. Now, whenever we're calculating means from frequency tables, I always do a dummy check, and I would encourage you to do the same thing. And what I mean by that is, does this answer make sense? So go back to our table, look at the minimum waist. The minimum waist size is 28. The maximum waist size is 44. So we know that our mean has to lie somewhere between these two values. And lo and behold, it does. It's quite nicely placed somewhere in the middle. So I'm going to be quite happy with that answer. So 33.68 inches. Okay, let's look at part B. So belts are made in sizes small, medium, large and extra large, which we can see. Jenny needs to order more belts in June. The modal size of belts sold is small, and we can check that. Yep, there's 24 that are small, so small is definitely the mode. Jenny is going to order 3/4 of the belts in size small. Now the manager of the shop tells Jenny she should not order so many small belts. Who is correct, Jenny or the manager? You must give a reason for your answer. So Jenny says that she should order 3/4 in size small. So let's work out how many, from the ones that we've got, how many are small. So we know that there are 24 small. So 24 small. And there are 50 customers in total. So from the sample, it's going to be 24 out of 50. Now 24 out of 50 is approximately a half, because if we think about what a half is 25 out of 50, so this is approximately a half. So she's definitely wrong, because 3/4 is way too many. So the manager of the shop tells Jenny that she should not order so many small belts. The manager's correct. She should order approximately half. So we could say that the manager is correct. The manager is correct. And then let's just say how many she should order. So Jenny should order approximately, and I'm just going to do that symbol for approximately, half in small, not 3/4. Question 25. The diagram shows part of a wall in the shape of a trapezium. Karen is going to cover this part of the wall with tiles. Each rectangular tile is 15 centimeters by 7.5 centimeters. Tiles are sold in packs. There are 9 tiles in each pack. Karen divides the area of the wall by the area of a tile to work out an estimate for the number of tiles she needs to buy. Use Karen's method to work out an estimate for the number of packs of tiles that she needs to buy. So we're going to use Karen's method to work out an estimate for the number of packs she needs to buy. So she divides the area of the wall by the area of a tile. Well, we can work out the area of a tile. That's quite easy, because we're just going to do base times height. So let's do it up here. So area of a tile, well, it's going to be 15 centimeters multiplied by 7.5 centimeters equals, let's get the calculator out. So 15 times 7.5, that gives us 112.5. So that's 112.5, and that is in centimeters squared. And now we need to work out the area of a trapezium. So there's a few ways you could do this. You could break it down into a rectangle and a triangle. So if I were to draw a line down here, break it up into a rectangle and a triangle. Or you could just do it all at once. So if you know how to calculate the area of a trapezium. So area of trapezium So we add the two parallel sides together. So 1.8 plus 2.7. And then we divide that by 2. Essentially what we're doing is we're finding the mean of the parallel sides. And then we multiply that by the height. So we multiply that by 0.8. So let's put this all into a calculator. So we've got 1.8 plus 2.7 divide by 2 times 0.8, and that gives us 1.8. So that is 1.8. Now we need to be really careful about our units because we're not in centimetres squared. Notice all our measurements are in metres, so that is in metres squared. So before we work out an estimate, we have to convert our unit or convert our measurements into the same units. So we can either use centimetres squared or metres squared. And I think what I'm going to do is I'm going to convert everything into centimetres squared. So this is another point where you need to be really careful because a lot of people will multiply this by 100 to go from metres squared to centimetres squared, but that is wrong. That is to go from metres to centimetres. We're not dealing with metres and centimetres. We're dealing with metres squared and centimetres squared. So we're not going to divide by 100. We are going to divide 1.8. So we're going to do 1.8. Sorry, not divide, multiply, I should say. So we're not going to multiply by 100. We're going to multiply by 100 squared. So it's just a difference between when you're dealing with just lengths and areas, you would need to multiply by your scale factor squared. Likewise, if we're dealing in volume, you would need to multiply by your scale factor cubed. Okay, so we're going to do 1.8 multiplied by 100 squared. 1.8 times 100. I'm just going to do times 100 times 100. And that gives us 18,000. So that is 18,000. And now that is in centimetres squared. And now we've calculated the area of the trapezium, we can work out the number of tiles she needs to buy by just doing this number here, the area of the trapezium, divided by the area of a tile. So we're going to do 18,000 divided by 112.5. So let me just put that into a calculator. And we get 160. So she needs 160 tiles. Now we're almost done, but the question says work out an estimate for the number of packs of tiles. So let me just highlight that. The number of packs of tiles. So we know how many tiles she needs, but how many packs is that? Well, there are 9 tiles in each pack. So we're just going to do 160 divided by 9. So divide that by 9. And we get 12.8. Sorry, not 12.8. 18.8. 17. I can't speak. 17.8 packs. Now, obviously, you cannot buy 0.8 of a pack, so we're going to have to round that up to 18 packs. So our answer is going to be 18. Okay, now part B. I did notice as I was sort of copying the questions over, there is a mistake in the question. So over here, this instead of tiles, you might have noticed this. It doesn't really make sense if it says tiles. That should say packs. Now let's read the question. It should make sense now. So Karen is advised to buy 10% more tiles than she estimated. Buying 10% more tiles will affect the number of packs she needs to buy, because before it said number of tiles, so that just completely didn't make any sense at all. Now she assumes that she will need to buy 10% more packs of tiles. Is Karen's assumption correct? You must show your working. So it says that she's advised to buy 10% more tiles than she estimated. Well, originally she was going to buy 160 tiles. So if she's going to buy 10% more, to work out the number of tiles that she needs, so number of tiles, well, it's just going to be 160 multiplied by an increase of 10%, which is just going to be 1.1. So this is 10% extra. So I think I can do that in my head. That's just going to be 160 plus 16, which is 176. So that is 176 tiles. And now we can work out the number of packs. So number of packs. So we're going to take 176 and we're going to divide that by the number of tiles in a pack, which we know is 9. So 176 divided by 9, and we get 19.6. 19.6, and then we're obviously going to have to round that up. So I'm just going to put an arrow. We're going to round that up to 20 because you cannot buy 19.6 packs. So originally she was buying 18 packs, and now she's buying 20 packs. So is this an increase of 10%? Well, let's work it out. So what is an increase of 10%? So 10% extra, if we started off with 18 and we wanted 10% more packs, well, we're just going to multiply that by 1.1. So 18 times 1.1. And that gives us 19.8. 19.8 packs. So let's answer the question. Is Karen's assumption correct? No. It's not correct because 10% more packs would be 19.8 packs, which doesn't really make any sense. In reality, she needs 20 packs. So we can say, no, she's wrong. She needs more than 20% or more than 10%. More than 10%, say extra. More than 10% extra of packs. Because 10% would be 19.8 and she needs 20, so she needs more than 10%. Question 26. Factorise x squared plus 3x minus 4. So let's just write this down here. So we've got x squared plus 3x minus 4. So this is a quadratic. And when we factorise these types of quadratics, there's a sort of certain rule to follow. What we're looking for is we need two numbers that when they multiply together, they give us this number. So something times something is equal to -4. But when we add them together, we need to get this number here. So let me just circle it. So two numbers that multiply together to get -4, but add together to get +3. So it'd be something plus something equals 3. So what numbers can we think of, first of all, that multiply together to get -4? So let's write them all down. So we could have -1 multiplied by 4. That will give us -4. We could have -4 multiplied by 1. We could have -2 times 2. And I think that's it, actually. I don't think there are any others. So these are the candidates. You could think of them as candidates. So which pair sum together to give us 3? Well, the top one. 4 plus -1 is 3. None of these ones would work. This would give us -3 and this would give us 0. So these are our two numbers that we're going to use. So what we do is we get two sets of brackets. And in one of the brackets, we put x minus 1, and the other one, we put x plus 4, And that is our answer. And you can always check your answer whenever you're factorising by doing the inverse operation, which is expanding. So if you expand these brackets and simplify, you will be left with this. So I'm not going to do it here, but if you want to verify that, you can. So our answer, I'm just going to write it down here, x minus 1 in one bracket, and then x plus 4 in our other bracket. Question 27. Here are the equations of 4 straight lines. 2 of these lines are parallel. Write down the 2 parallel lines. So the key thing to remember here is that parallel lines always have the same gradient. So if we can identify 2 gradients that are the same, we know those 2 lines will be parallel. And the easiest way to do that is to put them in the form of y equals mx plus c. So if we put them in this form, we know that m is the gradient. So line A, we can see line A is already in that form. So the gradient of A, let's write this down. The gradient of A is 2, because it's just m in this case. Now if we think about line B, so line B, at the moment it's not in y equals mx plus c form. So we need to rearrange our equation. So at the moment we've got 2y equals x plus 4. We just want y on the left, so if we divide both sides by 2, we get y equals a half x plus 2. I just divided everything by 2, and now we can see the gradient is a half. So the gradient of B is a half, so those two are clearly not parallel. Now let's do line C. So we've got 2x plus 2y is equal to 4. And again, we're going to try and get it in this form. So the first thing to do is get rid of the 2x. So if we subtract 2x from both sides, we get 2y is equal to negative 2x plus 4. And now we just want to get y on its own. So if we divide everything by 2, we get y is equal to negative x plus 2. So now we can see our gradient is negative 1. So for C, the gradient is negative 1. So they're all different at the moment. So D must be one of the lines. It must be parallel to one of them. So line D, we've got 2x minus y is equal to 4. So let's put y on this side just to make it positive. So if we add y to both sides, we get 2x is equal to y plus 4. And now if we subtract 4 from both sides, we get 2x minus 4 is equal to y, or we could just say y equals 2x minus 4. So now we can see our gradient is 2. So for D, our gradient is 2. And hey presto, we have two that are the same. So the parallel lines are A and D. Question 28, and the last question of the paper, which is obviously the last paper of the entire series, which you'll be happy about, I'm sure. So, question 28, the densities of two different liquids, A and B, are in the ratio 19 to 22. The mass of 1 centimetre cubed of liquid B is 1.1 grams. 5 centimetres cubed of liquid A is mixed with 15 centimetres cubed of liquid B to make 20 centimetres cubed of liquid C. Work out the density of liquid C. So there's an awful lot going on here, which is why it's worth 4 marks. So first of all, how do we calculate density? So I'm just going to put up here in the corner one of these triangles, because I always like to use these just as a visual aid. So to calculate the density of an object, we do the mass of that object divided by the volume of that object. So because we're working out the density of liquid C, we need to do the mass of liquid C divided by the volume of liquid C. So what information do we have so far? We know the ratio of the densities. Now we've got the mass of liquid B, which is 1.1 grams, and we know the volume of liquid B, which is 1 centimetre cubed. So we can calculate the density of liquid B. So let's do that. So let's write this down. So density of B, where we're going to do the mass divided by the volume. So it's going to be 1.1 grams divided by 1 centimetre cubed. And that's quite easy, because if we're dividing by 1, we just get that number. So that's going to be 1.1 grams per centimetre cubed. So that is the density of B. And now let's use the ratios, because if we can use the ratios now to work out the density of C. So the ratios, so let's write this down. So the ratio A to B is 19 to 22. We know the density of B, that is 1.1. So we can now work out what this density of A is. And there's a few ways we could do this. The way I'm going to do it is I'm just going to look at the scale factor between A and B. So how many times bigger is B compared to A? So we can just do the scale factor will be 22 divided by 19, which it gives us a long decimal. So I'm just going to leave it as a fraction. So that's just 22 over 19. So to work out the density of A, we can see that A is smaller than B. So we're going to divide this number by the scale factor. So we're going to do 1.1 divided by our scale factor, 22 over 19. And when I put that into a calculator, I get 0.95. So 0.95. So that is the density of A. So let's write this down here. So density of A equals 0.95 centimeters cubed. So we've got the density of A now, And we've also got the volume of A, because we can see in this line here, it says 5 centimeters cubed of liquid A is mixed. So if we've got the volume and we've got the density, we can now work out the mass of liquid A. So let's write this down here. So mass of A, well, that's going to be the density multiplied by the volume. So it's going to be 0.95 multiplied by the volume, which is 5. So 0.95 times 5, we get 4.75. So 4.75, and that will be in grams. So we've got the mass of A. Now we need to work out the mass of B. So mass of B. And be really careful, because we're told up here it does say mass. So it says the mass of 1 centimeter cubed of liquid B is 1.1 grams, but that's only 1 centimeter cubed of liquid B. If we look in the next line, it says that our mixture contains 15 centimeters cubed of liquid B. So if 1 centimeter cubed is 1.1 grams, 15 centimeters cubed, well, we're just going to multiply 15 centimeters by 1.1. So it's going to be 15 times 1.1. So 15 times 1.1, and that is 16.5. 16.5 grams. So now we've got both of them. Now we've got the mass of A and the mass of B. The mass of C, well, we're just going to add the two together. So it's going to be 4.75 plus 16.5, which gives us 21.25. So 21.25 grams. So we've got the mass of C. We need to work out the volume of C, because remember, we're trying to work out the density of C. So the density of C will be the mass of C, which is 21.25, divided by the volume of C. So the volume of C, well, that's a bit easier to calculate. We're just going to add the two volumes together. So it's just going to be 5 plus 15, which equals 20, and that is in centimeters cubed. So now the density of C is going to be the mass, which is 21.25, that's grams, divided by, I'm getting a bit lost here because there's so much going on, divided by the volume, which is 20, so 20 centimeters cubed. And I think we deserve probably a bit of a drum roll, because it's been quite exasperating getting to this point. So we're going to divide that by 20, and we get 1.0625. And let's just check our units. I can see that the answer gives the units as grams per centimetre cubed. And notice we've got grams divided by centimetres cubed. So that is grams per centimetre cubed. So that is our answer, 1.0625. So we have come to the end of this video, and this series of videos are on the foundation tier maths GCSE papers. So I do have a few more foundation papers on my GCSE walkthroughs playlist if you'd like to have a look at those. So if you are preparing for your mock exams or for your actual exams, I wish you all the best, and hopefully I will see you in the next video. Take care.